Most people believe numbers never lie. If statistics shows something works better, then it must be better, right? But there is a strange statistical phenomenon where the exact same data can tell two completely opposite stories, and both stories can be mathematically correct. This is called Simpson's paradox, and once you understand it, you will never trust statistics the same way again. Let's imagine a simple scenario. Two hospitals are testing two treatments for a disease, treatment A and treatment B. The results seem clear. Treatment A saves 90% of patients. Treatment B saves only 85%. So treatment A must be better. Case closed. But now something strange happens. When researchers separate the patients into two groups, mild cases and severe cases, the results completely flip. In mild cases, treatment B actually works better than treatment A. In severe cases, treatment B also works better than treatment A. So how is this possible? How can treatment A appear better overall even though treatment B is better in every group? This is the heart of Simpson's paradox. The trick lies in how the groups are distributed. Imagine most of the mild cases were given treatment A, and most of the severe cases were given treatment B. Mild cases naturally have higher survival rates. Severe cases naturally have lower survival rates. So when the data is combined, treatment A appears more successful simply because it treated more mild patients. But when you compare patients within the same severity group, treatment B is actually the better treatment. The statistics did not lie, but they told a misleading story. And this phenomenon happens everywhere, in medicine, in economics, in sports, and even in university admissions. One famous example occurred at a university where the data appeared to show that men were being accepted at a higher rate than women. It looked like discrimination. But when researchers analyzed individual departments, they found something surprising. Many departments were actually accepting women at higher rates than men. So how did the overall numbers make it look unfair? Because more women applied to highly competitive departments with low acceptance rates. Meanwhile, more men applied to departments with higher acceptance rates. When everything was combined, it created the illusion of bias, but the deeper analysis told a completely different story. This is why statisticians say something very important. Data does not speak for itself. The way you group data can completely change the story it tells. Two analysts can look at the exact same data set and reach opposite conclusions, not because one is lying, but because they are looking at the data differently. This is why Simpson's paradox is so important. It reminds us that numbers are powerful, but they are not always straightforward. Behind every statistic is context. Behind every data set is structure. And sometimes the truth only appears when you dig one layer deeper. So the next time you see a statistic that seems obvious, ask one simple question. What happens when the data is broken into smaller groups? Because sometimes the biggest statistical trick is not in the numbers themselves. It is in how they are combined. And once you see it, you realize something surprising. Statistics do not just describe reality. Sometimes they can completely reverse it.